Today we are going to talk about AWS Elastic Compute Cloud. We might have used some servers to check out some services like S3 uploads, S3 downloads, or accessing S3 using access keys or roles. Today, instead of using the default configuration, we will go in detail about what is Elastic Compute Cloud, or in other words, EC2, and find out what are the different flavors or types of servers Amazon offers, and how you can customize them and how you can use them in your business scenarios to enhance the performance and deliver the business value that your clients are expecting. Let's go ahead in detail and find out more about Elastic Compute Cloud today. So that's a brief about the Elastic Compute Cloud, and this is me who is going to talk to you for the rest of the session. So the brief agenda for today is going to be what is EC2, what is, in other words, what is Elastic Compute Cloud, what are the different types of instance types that you have, and what are the common use cases, and we will cover the building blocks that is necessary for building those common use cases. Finally, we will do a hands-on show and tell. A demo will be shown at the end of the session. So Amazon EC2 forms a compute group of services. Here is a small group of the services that is relevant to us. It's been listed here, and we have EC2 here that is going to, this is the group of service that we are going to talk about. That is auto scaling, that is Lambda. We will all look at each of them one by one later. So let's go ahead and see what are the components that is making the EC2. There are EC2 is completely flexible, or it can be secure at the same time, and easy to start, completely controlled. All these features apply to EC2. The reason is you as a customer or a client of Amazon have been given the flexibility of starting the smallest of servers and the biggest of servers. There is no restriction on who can start what. It is not based on the amount of money you are paying Amazon, or a type of client that you are a premium client, so you can start this kind of servers. You are a medium range client, silver client, you can start only this kind of servers. The flexibility is given to you. You can choose the type of servers you want, and you can completely control how long those servers are going to run. You want to run it for 1 day, you want to run it for 10 days, irrespective of the number of days you are wanting to run those servers. You are given the complete control, and you can pay Amazon depending upon the hours that you are running it. And it is very easy to start. The reason I say this is the time taken to start a very small server and really a very big server, say for example a 1 GB 1 CPU machine, that is T2 micro, and say for example an M4 large or a M4 4x large, which is something like a 32 CPU, almost is going to be the similar time. It takes 1 or 2 minutes at the max, and you can start using the machine as soon as possible. So the time to start environment and then your time to go to your market is going to be completely compressed when you're talking about Amazon EC2, because everything is blazingly fast, and you should be able to set up your environment in hours rather than weeks or months that happens in an on-premise environment. And another one thing that we need to note here is Amazon calls them as instances. They don't call them as servers, because most of the EC2 instances are virtualized. Unless you are going to request for Amazon a dedicated hardware, everything is virtualized in Amazon. So the common terminology that gets used here is instances, and there are multiple instance types with different performance options and combinations that is available. Let us go ahead and see a little bit in detail. So we are going to refresh on our concepts of AZs and availability zones and regions, because that Amazon EC2 builds on top of those fundamentals that we have. So if you know that Amazon architecture is built on the main fundamental core concept of regions, that is, regions are distributed across the world, and you can choose the region depending upon your latency requirements or cost requirements or any regulatory requirements. And you have the flexibility of launching any instance in any of those regions. If you remember in the previous demos, sometimes we went to Virginia region, for example, EFS, and sometimes we are doing it in Mumbai region. You have the complete control of launching an instance in any of the regions that is Amazon is giving to you. So this is how the flexibility of choice of data center comes to you, and also the resiliency or regulatory compliance also can be met along with your latency requirements. So regions becomes even more important when you are talking about EC2 instances. So now we talk about availability zones within those regions. These availability zones ensure that you have a high availability, because in every region you have at least 2 to 5 data centers or availability zones. And when you launch instances in these two availability zones, you automatically ensure that your architecture is going to be highly fault tolerant or available and resilient to failures. And these availability zones are in a low latency network. What means that is, typically, these availability zones talk to each other in a millisecond latency or microsecond latency, and any data that is put in one availability zone will be available or picked up by the other availability zones instantaneously. So your failover time, or in other words, if an availability zone 1A goes down, your 1B will be able to support the traffic almost instantaneously. Your customers will not be noticing the difference that one of your data centers are gone offline. So that is the kind of fault tolerance Amazon has built into the design of availability zones. So whenever you're building an architecture or making a design for your client or proposing some solution to your client, you should take advantage of the availability zones and the architecture of fault tolerance built into the availability zones. So that is one core tenet that you need to imbibe in yourself to understand the EC2 architecture of regions and availability zones. Moving forward, let us look at the instances itself. The instances are completely resizable and they have a very reduced time to boot a new server instances. We spoke about this, whether it is 1 CPU or 10 CPU, the amount of time it requires to boot an instance is almost similar. Marginally few milliseconds might differ, but they are on the macro scale, you will not notice the differences. And another important thing is, let us say you want to launch 100 servers. When you're launching 100 servers, Amazon allows you to create 100 different requests. So all the server creation requests can go in parallel. You don't have to necessarily do them in sequence. So all your 100 servers can be brought up in a couple of minutes, and you should be having an environment of 100 servers in 2 minutes and start configuring them with using a Chef or Puppet or any configuration management tool. When it comes to load balancing, we have a completely different concept called elastic load balancer. The elastic load balancer will sit in front of your instances and try to do a load balance between your instances. But when you are talking about clustering or high availability, Amazon recommends using your AZs for high availability instead of installing some softwares like IBM Power Systems, Power HA cluster is there, or Symantec or Sun Microsystems Red Hat clusters are there. Instead of using those kind of clusters, you rather have one highly available database with master and slave in different availability zones, and your application servers distributed in both availability zones, and you front end them with a elastic load balancer. We will talk about load balancing later. For now, let us focus on the app and the web layer, that is EC2 instances. So moving forward, you can run as many systems or as few systems. That is, we spoke about it, whether it is one machine or 100 machine or 1,000 machines, it's absolutely flexible, and you have been given the power to choose what you want to use, and you are going to pay for what you're going to use. And you have complete control over everything that is happening in the instance. You don't want 100 instances, you just want to have only 10 instances. Go ahead and stop the remaining 90. Nobody's coming to say you started 100, I paid money for this 100 hardware, now you're saying that I don't need 90, I'm going to make a loss. So Amazon is not going to come and say that, which is typically what an on-premise infrastructure capex structure will be looking like. They will ask you to pay for all the 100, and then they would make you to pay for the remaining runtime as well. So all those kind of headaches are gone when you're talking about EC2 instances. So finally, there is a nice little quote from Dow Jones. Dow Jones is the financial market of America, and they say that their cost has been come down by at least, the velocity of deployment has come down by at least 30%, and they're spending lesser and lesser time trying to create a data center and more time on creating products. So quite often we hear this point that financial companies and banks don't go use cloud. But if you can see this note, this is coming from one of the biggest stock exchanges in the world, and they are coming out in the market and saying that we are using Amazon, and Amazon helps us to increase our product development. So this completely goes against the myth of people saying financial institutions don't use cloud, it is insecure and all those things. So if somebody comes back and says that to you, give them the same quote saying that Dow Jones is using it and it is publicly available. You can go and Google this comment from Dow Jones. Moving forward, we talk about a little bit about the hypervisor, that is the virtualization layer, or how the different instance types are available. So you can choose your instances by a wide variety of instance types. That is, those types are optimized for a combination of CPU, memory, storage, and networking capacity. And you get a lot of operating system types as well. You are not restricted, say, for example, a VMware Linux, VMware Windows, or you cannot run SUSE on my machine, or Ubuntu on my machine, or Windows 2012 on my machine. You get the operating system of all these choices, and not only just operating system, there are pre-packaged application softwares also available. You can install for example, a network firewall from F5 or Palo Alto network firewalls, or a pre-configured Beanstalk environment, or Tomcat, or JBoss environments are also available. So all these combinations with the hardware and software make it really easy to bring up your environments. Say, for example, you have a three-tier architecture and it needs a JBoss and an Oracle environment and a web server. You can just go and pick up the necessary hardware with a pre-built software and bring it up within 5-10 minutes. It is only the configuration part after bringing up the servers that is going to take time now. So let us look at in detail about the combinations of software, hardware that is available for us. That is the different instance types that is available for us to use. So long we were using the T2 micro. Now onwards we will start looking at the different instance types that Amazon provides. So on the left hand side of the group is your general purpose. Under general purpose, you have two different types of machines. That is the T series, that is T2 series. The 2 number is the generation. We will look at the naming convention a little bit later. For now, you just remember that there are two general purpose instance types that is available. That is the T series and the M series. The M4 series can be M4 large, M4 2x large, M4 4x large. So there are two types of servers which can be used for any type of workloads, which is general purpose. Like for example, you can use it for a compute intensive one, or memory optimized one, or not an optimized, memory intensive one, or a database, which is not having a very specific requirement for saying I want my CPU at this percentage only, I want my memory at doing an IO at this rate, or I want my network to be optimized at this rate. If you don't have any requirement very specific to these parameters, then go ahead and launch an M4 for your customer. Whereas when you have compute optimized, there are certain workloads like image processing or video encoding, which are highly compute intensive. That requires a lot of CPU cycles. Then you have three families here: C3, C4, and C5. These are all compute optimized instances. Likewise, you have your storage and IO optimized ones: I2, I3, and D2. Depending upon your IO requirements, say for example, you have a streaming media requirement. You're not converting or transcoding your media. You're just going to stream your media now. You're going to read it from your database or your media store and stream it to your clients. For typical example would be Netflix here, or Amazon Prime Video. So the data is there, videos are there. You need to pick up the file and then stream it to thousands of customers in a very nice organized stream which doesn't get disturbed or latency requirements. Then you use any of these three instance families, that is I2, I3, and D2. Any of these things should work properly. But if you have a requirement for a memory optimized one, say for example, you want your database to be thoroughly memory optimized to have millisecond responses for your client, then you look at the memory optimized ones. You have plenty of options here. The X1, which is the biggest server that Amazon offers, is sitting here, and you have the R3 and R4, little older generations. compared to the X1, or difference in performance is huge here. The X1 is one of the best that your money can buy. And finally, you have completely different instance types. This is field programmable array. That is, you are given a memory module which you can write your own programs and decide how the CPU and memory architecture should work. For example, highly computationally intensive machine learning algorithms or artificial learning algorithms can take advantage of these instances, and they use this kind of instances to create supercomputers or clusters of computers which are like 70,000 nodes, 80,000 nodes together. So when they work together, you work on problems like weather patterns or computational dynamics for space launches, all those kind of things. So you get from the basic, that is the T2 micro that is on the left hand side, to all the way up to the supercomputer level power in the cloud. So you choose what you want to run and how many instances you want to run. The power is given to you and absolutely flexible as well. So there is no restrictions here. So some use cases when you to use what, say for example, as I was talking to you, general purpose, that is T2 and M series. When you have a low traffic websites, small databases, mid-range databases, ideally they form into the T2 use case. And if you want a computationally intensive one like a video encoding we spoke about, that is here, or high performance front end. For example, what I mean by front end is a web application layer. If you have a very high performance requirement saying you want millisecond responses to your client, then you look at compute optimized. And when we come to memory optimized ones, we are talking about the highly performant databases or distributed memory caches. If you want the database to be really good, or if you want a streaming workload of media data, then memory optimized ones looks very good. And storage optimized data warehousing, big data computations, and all those things. And the GPU or the field programmable arrays, they were used for machine learning, artificial learning, and 3D application streaming also. So these are the use cases, and if anybody is going to ask you what you are going to use these instances for, these are the some of the common answers that you need to provide them. And there are many more also. This is just a representational answer for the use cases. There are many more out in the world. Go and find out, learn more about them, and choose the appropriate instance for your client. So as I spoke about, this is how the naming convention of a server looks like. Typically when I say C4, this is the instance family, whether it is memory optimized or CPU optimized, or it is RAM optimized or field programmable array, that is C, that is the first group of letter. And when the next number is talking about the generation, that is, this is an Amazon generation, not the CPU architecture by Intel or some other CPU architecture company. Amazon has its own generation of families. So when it is 4, this is the fourth generation of the family. Earlier there was C3, C2 were there. Now we are in C4. And finally, when I say large, it means that there are two CPUs are here. Large is, yeah, one CPU is there. When we say 4x large, that means two CPUs into 2 times the existing CPUs. And as we say here, 4x large, that means the 4 times the base model size. So that is how it goes all the way up to 8x large. So that is how the different sizes looks like. Let us look at that little bit more now. So this is how it looks like. You have the C4X large, that is 8 CPU cores, and then when you have 2X large, it is having twice the capacity. And this is how the different CPU structures looks like. When you go and choose the instance sizing, you are going to choose the appropriate ones. So when your client says, I want a C4X large, I'm here on the left hand side. When I want a C4 8X large, that means that it is equal to launching 8 C4X large machines on the right hand side. So you get a one machine which is 8 times powerful as the base machine. So this is how the naming convention works. So this is how you need to decide on how is the CPUs are also calculated. This is not an interview question or anything, but you should know how this, what is 8x means, what is this 4x means, what is this 2x means, and then you have to choose and recommend your client appropriately. So here's the interesting information about metadata. So let us say you have launched your server and you want to know some information about your server, or you have given some information or passed on some startup scripts or boot scripts, or in other words, you're bootstrapping your server to run some packages or install some packages at boot time. So if you want to find out that information, so these are all the places where you'll find. When I say instance metadata, it is talking about the data about your instance, the hardware configuration, the network configuration, the IAM role it is using, the security group it is using, what is the 64-bit architecture, all those kind of things. And it can be used to dynamically configure your instance or find out more about your instance. Say, for example, you have created chosen in C4 instance and you are using a particular role. So if this combination is there, install this particular package. You can do those kind of algorithmic rules and install certain packages in your configuration script. So where does this script comes from? The script is given in the user data field, and in the user data field you can pick up the values from your metadata field and start configuring it so that it looks as and meets your requirements. Some people will say that while my instance is booting, ensure that it has this HTTPD package pre-installed, or when my instance is booting, ensure that it is taking a snapshot immediately after it comes online. So you can have any combination of user data, and remember that always the user data field triggers at the instance start, and anything that you put in here will start running at the beginning of the instance itself. And quite often people use that to automate your configuration management tasks, because if you're spinning 1,000 instances, you don't want somebody to manually go to 1,000 instances and install a web server, which is a very simple package. All you have to do is install HTTPD, and you can use the instance user data field to do that. So that is all is there for instance user data and metadata. Let us see how to retrieve them. So for retrieving the metadata, there is a standard default URL is there. When you log into the server, whether it is a Windows or Linux, the URL is the same. This is the URL that you see in the top, and if you go to a browser in a Windows instance and you type in the metadata field, you get all these options. And when you say, for example, when you add this field after the slash, you will be able to get a reply for the AMI ID. We will talk about AMI ID. AMI ID is nothing but the OS image number, reference number, or in other words, Amazon Machine Image Identifier. Or as I said, you can find out about the instance ID, you can find out about the public keys, you can find out about what is the MAC address or the network, all those things. In Linux, you do something like a curl and then the URL and the full URL, then you should be able to get the responses. And all the responses are in text and plain text. So you should be able to process them in your bash scripts or any other scripts easily. It is not in JSON, or it is not a dictionary, or it is not in some other format where you need another package to format it. It is all in plain text, so you can consume it in your scripts easily. So this is about the retrieving the metadata. Let us go ahead and see the user data. So when we are talking about user data, there are two ways you can get your user data script into it. There is one is the cloud init, and then another is this is for the Linux instances, you use the cloud init service, and for the Windows instances, it is run by the EC2 config service itself. Basically, when you're trying to launch an instance, there will be a user data field and you'll put your data there, but how it gets executed is where the difference is. Amazon has written a pre-built package called the cloud init for Linux instances, and for Windows, for starting at boot time, it uses a EC2 scheduled config service, and that executes your scripts. So let us go ahead and see what is cloud user data and how to retrieve the user data. We have almost a similar URL for user data as well. Yeah, if anybody is familiar with in Linux world, the RC scripts, that is runtime control scripts, start scripts and kill scripts, it is on init scripts. It is very much similar to that, or in fact, it leverages those init scripts and runs these startup scripts in Linux world. And Windows, they have created some plugins so that the EC2 config service works with the Windows boot process, and then it configures it after the Windows boot is completed. So how do let us say this is the script that I want to install in Linux. Say for example, yum install httpd systemctl enable this. The second command will ensure that my httpd starts up when my server is beginning, or when a server is booting, and the last command will ensure that my service is started for the current instance. So this is the script that I want to run in Linux. So how do I put it into my user data field? So what this is a little bit of more of an explanation. My user data field should always begin with identifier, so that my user data script understands whether it is a bash script or a Python script. So your interpreter is almost always mandatory, and you write this below steps for configuring your web server. There you can write it as a script and then put it in your S3 and link it also. That is also possible. I'll show you how to do this in the GUI console so that we can easily understand or how to demo this. When it comes to Windows, almost similar. If anybody is familiar with the PowerShell, they should be able to quickly read this. You are informing the PowerShell interpreter at the top, and you are importing the Windows Server Manager module. And then in the next two steps, you are installing it and configuring the IIS web server. So this is how user data field is done in Microsoft or in Windows. How do I retrieve the data? Almost a similar URL. Instead of metadata, we are just going to change the last part. The 169.254 is APIPA IP address. It is almost universal and it works in all the instances. And you just type in latest / user hyphen data. And when you do a curl in Linux world, you get all these fields. That is the entire data that was in the user data field is given as a plain text to you. And you can do the same thing in Windows as well. You can go to your browser and navigate to this URL. You will definitely get the reply. So instance lifecycle. So let us look at instance lifecycles. So let us say you have an Amazon machine image and then you are launching it. Let us say there's a Linux instance or a Windows instance and you are launching it. So it from the moment you launch it, it will be in the pending state. When I say pending state, that means that Amazon is trying to find out the necessary hardware in your region, and then the architecture and the CPU and the machine images, and tries to bring it into the running state. So you will most probably notice the pending state for a very small amount of time, and it comes to a running state almost in a minute or so after it completes the checks. So before it comes to the running state, or it has to comes to that, there are a lot of checks that happens. Mainly, most importantly, it does a lot of hardware checks, whether the hypervisor is good and the underlying network level is good and it is able to manage the traffic, and all those kind of checks are performed. So once those are completed, your server reaches the running state. So from it, the moment your server or instance is in running state, it can reach two more states. Say for example, you initiate a stop from the control panel. It immediately enters a stopping state, meaning it is going to get stopped. So because you can configure some scripts to trigger some actions when it's in the stopping state. Say for example, take a quick snapshot of the server when it has entered stopping state. So at that point of time, you can trigger a snapshot or take some other backup activities, or take some other activities like a failover to another instance or something like that. So it will be in a stopping state for a very brief moment of time, and then finally it will reach the stopped state. So during this point, when you have an EBS volume or any storage attached to it, remember that those storage volumes will remain, or it will remain attached to the server itself. The storage is still available, so you can start that server during this time or restart the server at any point of time, because the storage is still available to you. So instead of stopping, what you do is you, let us say after the running state, you initiate a terminate option or a okay, let us say you are starting it again. The server has reached the stop state and you are going to start it again. Then it will go to the pending state and then it will reach the running state. Because your storage is still available, you will be still having a running server and all your configurations will persist across this stop and start. So the another state available is you can reboot your server after when you're in running state. When you reboot it, there is no in between states. You just go initiates the reboot and almost instantaneously. If you're looking at the console constantly, you will find the state changing to rebooting. That exact word will appear on your console, and almost instantaneously it will return back to running state. What it does is it just refreshes the memory caches and puts your hypervisor into, I mean, if you put your server into another hypervisor and then starts it running. So this state is almost fleeting. If you're not looking carefully, you won't even see this. So that is how fast the reboot action takes place. Now you are back into a running state, your server is running, you're doing some lot of operations, and finally you don't need the server. Then you initiate a terminate, right? You initiate a terminate, then your server reaches a shutting down state, and then finally it reaches the terminate state. And when you do this, your EBS volume is no longer attached. Any other storage or pre-configuration that you made in your server is lost at this point of time. And you can reach the terminated state from your stopped state as well. So you can jump from here all the way to the terminate directly, and your EBS volumes are detached, and you can reach the terminated state. So when your instance is running, you can reboot the server at any point in time, and if you're not watching the console quickly, you will not even notice the rebooting state that appears on the console. It almost happens instantaneously. Amazon reboots the servers or instances really fast, and once you reboot it, you can reach back to the running state again. During this point, there is no changes to your EBS volumes. Your EBS volumes are still attached and your data is still available, and you can reboot your server any number of times. So now we are in the running state. From this point, you can terminate your server, or even from your stopped state, you can terminate your server. So when you initiate a terminate in your console, what happens is, if it is in the running state, it reaches a shutting down state first and then goes to the terminated state. So during this process, your EBS volumes are released and you no longer have access to the data that was configured, or any configuration that you had done to your server is lost. Unless you take a machine image during before the terminate is triggered, you will not be able to retrieve the configurations or any changes that you made in your server. These are the different states a server enters when it is in its life cycle. So when you're launching, it reaches a pending, and then from pending, it reaches a running state. Once it reaches running state, it can be rebooted or it can be stopped and started, and finally terminated as well. So depending upon the different states, pending, stopping, shutting down, you can configure some other actions in your server by using CloudWatch monitoring or some kind of other monitoring alarm systems. You can ask Amazon through an API call asking, what is the status of my server? Is it pending, or is it shutting down, or is it stopping? So based on the response that you get, you can trigger some actions. Either it can be a recovery action or a snapshot action. Depending upon your requirements, you choose that actions. And always remember that only in EBS volumes the data persists. If you are having an instance store at this point of time where you are stopping and starting, your data will not persist. Whereas when you are doing a reboot, your instance store will persist, but not for stop and start or terminate. So that is about the life cycle. Let's just move forward and see what else we can do here. So today we are going to quickly do a hands-on demo for EC2. These are the different things that we are going to do here.